Okay, so you're all welcome to this our meetup. So today we will be talking about money saving tips for the Frugal serverless developer. So I know most of us are concerned about cost. We always want to minimize cost or improve revenue at the same time, make sure our workloads are profitable in the cloud. So we have a serverless hero here, an icon, a legend. So, Jan, I'll just let you introduce yourself and tell us a bit about yourself and what you're going to share with us today.
Yeah, sure. Yeah, prepare some slides. About about how basically how to save money with AWS service environment. Mostly, a lot of places are things that people really not used to thinking about. So my name is Yan. I've been building stuff on AWS since about 2010. Went through the whole journey of shipping everything on EC2 to containers to then the I guess 2016 was when I pretty much entirely focused around serverless and just discover how much life is better if when you're just letting AWS handle all of the infrastructure and security and all of that. And nowadays I work with the Lumigo team as a developer advocate, and Lumigo to me is still probably the best observability platform, especially when you are mostly working with serverless services. Um, the other half of my time, I work as an independent consultant, where I work with other companies to help them adopt serverless and to avoid many of the sort of kind of things and mistakes that I've made along the way. And one of the things I like to do also as well is I like to identify little patterns and little things that I can use to help me reduce my cost for my applications. And so I like to just share a lot of them with you. So I hope you like drinking from the fire hose. In terms of the some of the tips for saving money on your serverless environment, just in AWS in general, I think one of the first things that everyone should be doing is to set up a billing alarms. Is something that if you're new to AWS, especially you don't really know what you're doing. The first thing you want to do is make sure that you've got some safety net, and that's why you want to have billing alarms in place. They're not perfect by any means. They are usually maybe like 4 or 8 hours behind real time, but it's much better to find out that you got a problem a few hours late than to find out a few days or a few weeks late when you actually get your bill. Um, so a good example of how billing alarms can save you. A good friend of mine, Luke, who works at the PostNL, which is the national postal office as well as service in the Netherlands. So they had a billing alarm triggered on their account or on their specific account for one of the services that Luke is working on. Because they had what happened was they had their service is fetching secrets from Secrets Manager. They made a one-liner change to that one function, and it broke caching. So instead of cold start, go to Secrets Manager and then caching the secrets, they were making a call to Secrets Manager on every single invocation. And when you're the national postal service, you do make a lot of Lambda invocations every month. So suddenly, this you can see pretty much in the straight away that as soon as they make that code change, the cost starts to go up for the cost for the calls to Secrets Manager. So they figured out this was a problem when the billion alarm got triggered. I think it's about 2 weeks into the situation. But if they hadn't had a billing alarm in place and nobody was going to them and nobody was checking their AWS bill every month or well, regularly, then there's a really good chance that um, you are not going to. Oh, hey, Daryl, thank you. Yeah, I think you've seen do you not see the full screen thing? Okay, right. My bad. I probably shared the wrong screen. Let me share my screen again. Share screen, second desktop. Let me try so that you don't so you see the full picture, not just a tiny bit here. What about now? Is this better? Are you seeing the full screen?
Yeah, that's great. Thanks. I just didn't think you wanted to be sharing your other section.
Yeah, yeah. That's just for me to see what's coming up, but I didn't realize I was sharing the small screen so that you only see a tiny bit. But if you go back and see, this is where I was talking about, when they see as soon as they make that mistake, the cost will start to go up. So you can see in that little diagram on the right that those calls to secrets manager, because they're making a lot of calls every day, it was just, you can see that quite clearly that when they made that mistake. So yeah, so I found out about this a few, I guess 2 weeks into it, but it can really easily have been months before anybody noticed if they didn't have the billing alarm in place, and maybe the finance team or accounting team are not checking the AWS spend regularly as well, because they don't really know, what are you guys doing in the applications. Oftentimes when there's changes in the cost, maybe, for as far as the accounting team is concerned, if it might just be, oh, this is the expected. So that's why, as a team, you owning your services, you should also always have some billing alarm around your account, so that when there's a problem, you are then notified, and so you can get it under control pretty quickly. In terms of cost, in serverless environments, I find that by far the most common sort of thing that people overspend on are around the CloudWatch. In most of my customers' AWS bills, CloudWatch is almost pretty much always in the top three, and oftentimes costs a lot more than the actual application itself. So if you think you're building, APIs, REST APIs with API Gateway, Lambda, DynamDB, and so on, oftentimes you find that CloudWatch costs more than those services combined. And the worst thing is that as you spend more money because you're collecting more data from CloudWatch, especially around CloudWatch logs, then the value of what you're collecting is actually goes down, because now you've got much more data you have to sift through and look for the actual needle in the haystack. A couple of things that I normally like to do to help keep my CloudWatch logs cost under control is make sure that I'm doing structured logging, so that every time I log something in my application, I think really carefully in terms of what category this log message belongs to. Is it just for debugging, so that I have a fine-grained information about exactly what's happening? Is it some general information? Oh, we just started this process, or we initialize caching, and if it's an error, but then we can continue, we can handle the error and move on. Then it could be a warning. But then if it's something that we like HTTP request, and we have to call a third-party service, and the third party responded with I don't know, 500, and we can't proceed without that. So we have to just throw an error, and also record that error information as well. So in production, you want to make sure that you set your log level such that you don't record all the debug messages, because in production you're going to have so much more traffic, and the debug messages can be overwhelming in terms of the amount of data you're going to collect, and they can be quite costly. So instead, we also don't want to be in situations, or you want to kind of make sure that you're logging above the debug level, but also don't want to be in a situation whereby you have no debug logs. So typically what we do is I will set up a log sampling for debug, so that I will collect the debug logs for, say, about 5 or 10% of my function invocations or user requests if you're using, say, Fargate instead of Lambda, which is not an invocation-based model. But we just have a small percentage of logs, or user requests that are being processed and logging at debug level. That way, I should hopefully still have enough debug logs, so that for every sort of code path we have, when there's an exception, when there's an error, we're still gonna be able to have enough debug logs, so that we can find debug logs related to those errors. Also, by default, CloudWatch doesn't delete your data, and the default retention is never expire. Again, over time, your log's gonna lose value, but then you're still gonna be paying for that 3 cents per gigabyte per month over time as you collect more and more logs. So choose something that's more reasonable. Set your log retention to like 7, 14 days or what have you. Normally, logs doesn't need to be around for that long. They pretty much become useless after like a week or two. Another thing I've noticed a lot is that because trying to query logs across multiple accounts are still kind of clumsy, still kind of difficult, even though they have gradually made improvements to that. But a lot of customers are using other platforms to search and to store and query their logs. So oftentimes you see this kind of setup in those environments where you have log subscriptions filters, so that the CloudWatch log is going to call Lambda function, and then the people would ship that logs from CloudWatch to something else, something that they prefer to use instead. I don't have it here, but there's also Lumigo and Honeycomb and quite a few other services that I'm seeing more and more now compared to services that specialize around the logging. And so when you do this, one of the things that you have to think about is that, well, CloudWatch is still going to charge you 50 cents per gigabyte for ingesting the logs in the first place before they send it to your Lambda function to then process and so on. So you actually, and also whatever vendor you're working with, chances are they're also going to charge you for ingestion and storage as well. So in terms of the process, that initial ingestion cost, you end up paying twice, once for CloudWatch to do it, but then also again with the third-party vendor you're using, plus whatever Lambda Lambda related cost you have for processing those log messages. So nowadays, if you're using Lambda, there's actually a better way to do this with Lambda extensions and the telemetry API. So Lambda extensions is basically a mechanism that allows you to run some, let's call it a sidecar process right next to your main application function module process that runs your function handler code. But what it can also allow you to do is to subscribe to the telemetry API, which is a local API that's available to the Lambda function when it's running inside those Lambda execution environments, that allows you to allows Lambda extensions to subscribe to telemetry events, things like there's a new log event, there's a new trace and the metric and so on. So that way you can use those Lambda extensions to then ship the log messages and the stuff like that straight to the third-party vendor without having to go through CloudWatch logs first. But if you just do that, then it still doesn't stop Lambda from writing those things to CloudWatch in the first place. So when you have that Lambda extension installed and the shipping logs to your preferred vendor, you still want to have like a block IAM block a code here. So that stops Lambda from being able to write the logs to CloudWatch logs. That way you start paying for the ingestion at CloudWatch logs as well. And if you're looking for something that can allow you to ingest and query all of your logs, but also allows you to be able to treat all of your log as structured data, and so that way you can then create the metrics and the alerts against that. Then the Lumigo also do that as well. They offer logs ingestion platform that allows you to ingest all the logs from your AWS environment. But then what they don't do is that they don't charge you extra for turning those log events into metrics and then create alarms against that. So normally with CloudWatch, you do have the, say, embedded metric format with CloudWatch logs that you can then turn things into metric, but then you have to pay extra for the metrics and any alarms you create against them. So Lumigo's price kind of includes everything in one package. So that's why often you can be a lot cheaper compared to actually using CloudWatch directly. But with CloudWatch, and Lambda, there's also those system messages that you get for every single Lambda invocation. They can be useful sometimes, but then not everyone actually uses them. Like I was talking to Jack, who's the founder of Far From Analytics, and he was talking about how they were using they run the Laravel Vapor, and they write all the log events to their own database, so for them to query later. But then they still have to pay for all of those system log messages, and because they're doing billions and billions of invocations per month, so they were actually paying a significant amount of money for just those system messages as well. So luckily nowadays you have some more control around that. So when you configure your Lambda function in CloudFormation, and you can do the same thing in CDK, Terraform, and others as well. There's a few settings you can set. You can use nowadays to control what system messages gets logged. So one of the new settings is called the log format. So this is by default is just going to treat everything you write to standard out or standard error as text, but if you change the log format to JSON, Lambda is also going to just treat whatever message you're writing from your function to the standard out, just create like a JSON, very simple structured JSON message around it. But then once you have this log format set to JSON, you can also change the system log level. So now you can control which of the messages that you normally get from the Lambda platform, the system messages you want to see. So if you set it to 1, then you're not going to get any of those system start reporting and things like that. But if there's any unhandled exception and blows up your your application code, then you can still see those unhandled exception being logged in CloudWatch. But this is quite a nice way to cut down on a lot of those logging costs, but also just in terms of reducing the amount of noise you may have to deal with when if you're using CloudWatch with Lambda. So CloudWatch is one of those services that has got a lot of stuff going on, but most of the time people don't actually need it, and so there was so it's really good to understand and know what you can do with CloudWatch, even if you don't intend to use it always. So check out cloudwatchbook.com. Tobias and Sandro has done a really good job of explaining all the different facets of CloudWatch. And back in, I think this is recorded, so they also did a session at a community day over here in I think it was in Germany, talking about how they kind of they build a kind of like a observability stack around CloudWatch. I think it's recorded, so if you do a Google for this name, you may find the talk that Tobias did, which covers a lot of different things that, again, things that CloudWatch can do that many people are not using it to its full potential. So before you sort of sign a big contract with some other third-party vendor, also it's just good to understand what you can get out of the box with CloudWatch. As far as Lambda is concerned, this is probably the one main thing that you can do in terms of optimizing the cost for Lambda functions, because with Lambda, more memory equals more CPU and also more network bandwidth, but then you also get charged more per millisecond of execution time based on how much memory your function has. And the good thing here is that if you need extra power for your function, it's really easy to just say, hey, let's add more memory, and that's going to give us more memory, but also a lot more CPU power. But the downside is that you can get things wrong by an order of magnitude really easily. So something actually happened to one of my clients a while back. So I was working with a company. They do video rendering for some of those like hand-drawn animations I sometimes see on YouTube, those educational videos. So the team over there knew that, okay, more memory equals more CPU, and that they want to improve how the rendering process, how long it took to render a video. And so they bumped up that rendering function from, I forgot where it was from, but they went all the way up to the maximum 10 gig. What they didn't realize, however, was that it's not just going to get a bigger CPU. Instead, every 1.8 gig, you unlock another virtual CPU core. So at 10 gig, they had access to 6 virtual CPU core. But to take full advantage of all that CPU power, you have to write your code to take advantage of multi-core. Unfortunately, they were using Node.js, and the Node.js is runs on a single threaded event loop. So even though they were paying 10 gig, they were only getting the CPU power, the CPU resource equivalent to 1.8 gig. So most of what they're spending was being wasted, and that's when they asked me to help, and the tactical fix was to just reduce the memory setting to 1.8 gigs, so that you get the biggest one core, you get like one entire CPU core, so that you improve the performance somewhat to whatever you can do with one core, and then rewrite the application so that the rendering process can actually take advantage of multi-core. Then you go back to 10 gig. Then your spending for per millisecond is higher, but then you also proportionally reduce the amount of time it takes to render a video. So then your overall cost shouldn't change too much. And this is where things like, well, this is where people can go too far to the other extreme as well. I'll probably see far more problem with memory setting being too low than too high. So I know I just gave you an example of a company that has wasted a lot of money just because they went all the way up to the maximum, but they weren't able to use all the CPU power. But far more often, I see people try to start with a very conservative 128 meg of memory setting for their function, but instead their cold starts would be several seconds for Node.js function that normally can cold start in say 500 milliseconds, and the performance really suffers because even if you don't use all 128 meg of memory, the fact that the Lambda, the Node.js runtime uses some of that, but also importantly, when you hit about 60-70% of memory usage, OS level paging started to happen so that the OS give you the illusion of having more memory than you actually have a physical memory available so that you can do more things. But paging, which is reading and writing data between memory and the disk is super slow. So suddenly you see functions that normally can run in 5 milliseconds, taking 500 milliseconds. So you can make a big difference in terms of performance, which is why I want to bring up this famous quote from Donald Knuth that 97% of the time we should forget about small efficiencies. Premature optimization is the root of all evil. So most of the time, just slap somewhat big but not huge default memory setting on your Lambda functions. I still go with 1 gig. It still makes sense for most of my functions. But once you identify that critical 3%, that's when you want to make sure that you're right sizing the memory settings for your function. So with Lumigo, they kind of show you the memory setting for all of your functions in your AWS environment, but also the estimated cost for your function. So as you can see, none of the function here cost me enough to warrant any kind of effort around optimization. So most of the time, I also find AWS environments where most of Lambda functions, the cost is very minimal. So there's no value to optimizing it. So again, put something that's somewhat big enough, more than big enough, like 1 gig, so that you don't have to worry about the memory issues. You don't have to worry about the memory related the performance issues for your functions, and only for things that have to run a lot or have to run a very long time or both. Then you start optimizing based on the spending you have on those specific functions. Typically, they account for like less than 1% of the functions in your AWS environment. So that's where you want to right size the settings, the memory setting for your function. So the way you can do that, there's several ways to do that. The way that I mostly do is use the Lambda power tuning tool, which is step functions that you can say, here's my Lambda function. And what it will do is it will create the multiple copies of the same function so that you have a version with 128 meg, one version with 256, 512, 1 gig, 2 gigs, 3 gig, and so on. And then it will run, say, 100 invocations based on the payload you provide across each one of those variants, and you show you a graph of plotting the performance, like latency duration, against the total cost based on how long it took and the cost of per millisecond of execution time. So as you can see, by and large, adding more memory, even though it increases the cost per millisecond, actually reduces your overall cost, because even though it's costing you more per millisecond, but you're running faster, so you have fewer milliseconds of the execution time, up to the point where here, because this function code is also single-threaded, the Node.js code. So once you go over 1.8 gig, you're not getting any more performance out of it, but you're spending more per millisecond, and therefore it's going up. And that's exactly what happened to my client. They weren't doing multi-core, and so they were full 10 gigs, so their cost was all the way up somewhere to the top right there. Another thing you can do is to switch from x86 to ARM architecture, because ARM per millisecond of execution time is 25% cheaper. However, performance between x86 and ARM can be pretty dramatic. So when AWS announced this support for ARM architecture way back, I think they quoted something like ARM is 25% cheaper per millisecond plus 19% faster performance-wise, and so overall you get like a 34% deduction on total cost. However, when I tested ARM against a lot of my functions, I actually found that they are typically slower than x86, and in the worst case, it was 6 times, or not 6 times, it was 60% slower compared to the equivalent function running on x86. So in that case, even though it's 25% cheaper per millisecond, but you're spending 60% more milliseconds to do the same task. So it end up being a lot more expensive if I had to switch to ARM instead. So always benchmark against your specific function to see whether or not you get a comparable performance from ARM compared to x86. But if you have got, say, functions that have to call some third-party APIs and spend a lot of time just waiting for a response, then ARM can actually be really good here because those idle time is being wasted anyway. So if you can get 25% saving on those idle time, then maybe, well, then it's definitely a good trade, and especially when just a single line of config change, and you can do this on a function-by-function basis. All right, so still staying with Lambda, this is probably the single biggest anti-pattern around working with Lambda. So having Lambda functions calling other functions synchronously. Now, everything you want to do with Lambda ultimately goes down to having the single invoke API. You can invoke a Lambda function. You can say whether the invocation type is going to be request response, in which case this is what we call a synchronous invocation, whereby your API call to Lambda to invoke function XYZ is going to respond when that function has finished running. So you can get its output, its response. Or you can do async invocation. So you can say find and forget, in which case the Lambda service is going to take your request. It's going to put it onto like an internal queue, and then later on it's going to get processed. The function's code is actually going to get invoked. So when it comes to invocations, synchronous Lambda to Lambda calls are pretty much always a bad sign. It's always almost a bad design. There's maybe like one or two exceptions, but by and large, when you see synchronous Lambda to Lambda calls, think, okay, this is a bit of a red flag here. This is something we really should be doing. If you're doing that across, say, two functions in the same service, within inside the same service, then oftentimes I find that this is a misunderstanding, or people trying to push single responsibility too far, or just maybe confusing Lambda functions in terms of the infrastructure sort of concept versus the Lambda functions in programming language, and try to break things down too fine into your both at the code level, but also at the infrastructure level. But you can have modularity just exist in the code. You can still have a lot of well-defined encapsulations and modularity in your code without those having to be reflected also in the infrastructure in terms of the resources you create within AWS. So instead of having two functions to do things, you can just combine the code. Again, make sure that you have good modularity so that they can happen within single Lambda function invocation, but modularity can still exist at the code level. But also see this sometimes that Lambda to Lambda calls happen because people are exposing. You're building microservices or some kind of different services, and you're exposing capabilities to other teams and other services by saying, hey, here's a Lambda function you can call to get inventory information, get information about customer, and so on and so forth. But the problem with this, as using Lambda as the kind of the API to your service, is that you're coupling your caller to implementation details that they shouldn't have to worry about. The fact that you're using Lambda to begin with, the fact you're running in a particular account, region, the name of your function, and so on and so forth. When you change any of those things, and you should be allowed to change all of those things without impacting anybody else. And if you just say, okay, I want to rename that function, now suddenly everybody that relies on your service have to change their code as well. So if you're building some kind of a service-oriented or microservice architecture, just give them a good old HTTP API endpoint that they can call. Today maybe Lambda makes sense for you, but maybe tomorrow you want to move that to Fargate or ECS or something else, whereby we are running a fairly high throughput. We want to get more cost efficiency around the paying for uptime instead of paying for individual requests. And when you do this, there's nothing impacting your caller. They're just calling the same HTTP endpoint. So they got a stable interface, and it allows you to just change and update your implementation details as and when you feel like it. So that's synchronous Lambda to Lambda calls, and why that's pretty much always a bad idea. But what about the asynchronous invocations? And I've actually found a few, maybe one specific use case that I actually use quite a lot, where it's a good idea. So if I'm building some kind of a user-facing API where a customer would want to do something like, oh, update my profile. So I have a user-facing Lambda function that handles that user request and is supposed to update the user profile in the database. But I also want to do some other secondary things like, oh, calling a Facebook Pixel API or some third-party tracking API so that I can keep track of the actions the users are doing, and I can use that to do the better campaign marketing and things like that. But I don't want those second responsibilities to add delay to the user seeing a response from my API. So what I can do is I can take those secondary responsibilities, put into a second Lambda function that is asynchronously invoked by the first function. That way, the first function can respond straight away because the call to invoke a function asynchronously just pretty much returns straight away. There's no delay because it doesn't have to wait for the code to actually run. So that gives me a better user experience. But also importantly as well, when there is problem with, say, the Facebook Pixel API, I can have a more kind of robust error handling around that to have multiple retries, also have exponential backup between retries. And this is not going to impact the user because all of that happens for the second function in the background because it was invoked asynchronously. So this makes sense if both functions are in the same service and the two functions are doing things that I would have done in the one function anyway, and I'm splitting them out so that I can improve the user experience by doing less important things asynchronously in the background. But if you still have this calls going to other services and exposing your API as Lambda functions, even if it's asynchronous, then that is still not a good design. So as far as async Lambda invocations are concerned, it really depends on your use case. My rule of thumb really is that every time you look at your architecture diagram, you look at the different components you have there, everything must provide a value for existing. If you can do everything in one function, do it in one function. But then if there's good reason for you to split things out into two different functions or multiple components, then there must be a good reason why doing that is providing some value. You could be improving your user experience. You could be improving your error handling and so on. But there must be a reason for you to do that. And moving on, caching. So caching to me is almost like a cheat code when it comes to building performant and scalable and cost-efficient applications. And if you just look at your typical serverless API where you may have root registry in front of a CloudFront distribution, and then behind that you've got your API gateway, Lambda, DynamoDB, and so on. I also want to do some client-side caching for things like static assets and config files that doesn't change very often. But for my API responses, I can do edge caching with CloudFront. And there's anything that I'm doing in my code that can be computationally expensive or takes a long time, I can also use application level caching and put them in, say, Elasticache, so that the next time we need to do the same computation, we can just check the cache first. But with serverless, I like the whole pay-per-use pricing. I don't like to pay for uptime, so nowadays I actually prefer to use Memento instead, which is a very nice caching solution, and they only charge you for usages, not for uptime. So if you don't have any traffic because it's your dev environment, then again you kind of just fit within that free tier, which is very nice. But yeah, in the cloud, one of the most important skills really is to know that AWS got all of these different services you can use, knowing what service does, but also how it fits into your architecture based on the sort of characteristics that you want from those architecture is important, because in the cloud, every architecture decision is essentially a buying decision that you're deciding what services to use and pay for and buy. And picking the wrong service can be very, very costly. So if you're building some kind of a message-driven architecture, you may use SNS, SQS, Event Bridge, Kinesis, and so on. And on the face of it, the Kinesis, because it's an uptime charge, uptime cost sort of dimension, it can often be more expensive if you have a low throughput of, say, 1 message per second. But as you go up to much higher number of messages, Kinesis is much more cost efficient. When it comes to ingesting a large amounts of event or data and processing in real time on AWS, Kinesis is probably the king in terms of cost efficiency. Because even though you are paying some uptime for the number of shards and streams you have, its cost per millisecond is much lower compared to the different services. And the same thing can happen with, say, ALB versus API Gateway, where API Gateway is a pure pay-per-use, whereas ALB has got an uptime element, cost element to it. So at low throughput, ALB can seem quite expensive, but then as you go up to hundreds or even thousands of requests per second, then suddenly API Gateway can be much more costly compared to ALB. Again, the ALB, the uptime cost often comes with a lower cost per million requests. So a good rule of thumb to have on AWS is that the services that charge you by uptime are going to be orders of magnitude more cost efficient when you're running at scale. And what scale means differs by company, of course, but typically when I think, okay, an API that's running at scale will be doing at least, say, like 1,000 requests per second or something like that consistently. But that being a good rule of thumb to have doesn't mean that you can just forget about the nuances, because it's important to always understand the specific cost dimensions to understand how that maps to your use case. Because what I showed you earlier was with the assumption of having a 1 kilobyte per the payload, either response or in the request per request, but if you're dealing with like a large payloads, and suddenly that picture can look very different to the point that it just becomes almost unthinkable to be using something like ALB, because data process is one of the cost dimensions on top of the yes, API Gateway still have charge for data transfer, so does ALB, but then on top of that, one of the things that it measures and charges you for is the amount of data that you process, and that's one of the dimensions it uses to calculate the ACU, the LCU, the load balancer compute unit, which means if you're dealing with a large payload for some reason, then it can become really expensive with ALB. So was it now 3 years ago that Werner gave us the Frugal architect, where he gave us several 7 laws for the Frugal architect, and there's 2 that I particularly like. One that says that architecting is a series of trade-offs. That's where having a bit of mechanical sympathy, where you understand the services you're using in terms of the behavior, the constraints, but also in terms of the cost, the pricing model is going to be important. And then the other law, which is to say that we want to build systems whose cost is going to grow along the same dimension as our revenue. That way, we don't have a case where revenue is not growing, but then our cost is going up because they grow on different dimensions. So as example for that, law number 2, I've built a number of systems that have some kind of a real-time element to it, and being a big fan on AWS Serverless, I like to use services that gives me WebSocket serverlessly without having to manage any machines. So you have API Gateway, you've got AppSync, and you've got IoT Core as well, which are all great, and they all charges you on same dimensions in terms of having number of messages that you're sending, and also how long are you connected to the WebSocket, the endpoint. But imagine you're building some kind of, say, a social network where the more users you have, the more connection time you're going to have to those WebSocket connections, because whenever they are DM'd, whenever they are mentioned in a post, you want to push an update to them so that they get notification and all of that good stuff. But then your revenue doesn't grow with just user, because most users they don't pay. Instead, you tend to find that it's the most engaged users that tend to convert into paying customers. And so your revenue actually grows more along the line of engagement. So the more engaged someone becomes, the more likely they are to turn into a paying customer. And so I want my revenue to grow along the line of engagement or activities as opposed to along with line of a connection time. Again, I want to just give a shout out to Memento there because they have they also have a topics which is think SNS topics, but then they can send you updates through WebSockets to the front end, so it's really easy to do back end to front end notifications. And the nice thing about them is that they don't charge you for connection time; they only charge you for the messages or the operations. So it's so compared to the other services that I mentioned on AWS, they can be the cost wise, depending on the ratio you have, it may not be that different, but then it allows you to model your system in terms of cost based on the dimension that your revenue is going to grow as opposed to just based on connection time. And speaking of picking services that are partners that you want to buy into, and that's gonna be cost efficient. So this happened a while back. A social network blew up, and it went from I think almost no users to 500,000 daily active users, and that they pretty soon got slapped with a bill from Vercel for $100,000 because Vercel is built on top of AWS and they have their own markup on top of the cost that they have for AWS. And specifically in this case, I think these guys were using Vercel functions very heavily, and Vercel has a 7x markup on the underlying Lambda cost, which is how they're able to, these guys are able to rack up such a big AWS bill really, really quickly. And I think in general, Vercel has got a really confusing pricing sort of cost dimensions. And they do so. If you're using Vercel, something you really going to be quite careful. They do have a nicely like a cost control mechanism. So whereas AWS only have billing alarms, it doesn't stop you from doing more once you hit your budget. Vercel actually has got a cost control spending cap so that you can say once I hit my limit, don't allow me to do anything more. So it gives you the option to choose downtime instead of overspending, whereas AWS doesn't give you the option. You just have a billing alarm to let you know that okay, you hit your budget. What do you want to do now? And that's up to you. And so those are just 6 tips on how to optimizing the cost efficiency for your server application. There's also other things to consider as well, but I want to keep this into something that's a little bit more manageable in terms of time. But yeah, if you've got any questions, happy to kind of answer them now. And if you've got anything after this, you can also just reach out to me on LinkedIn or whatever platform that you use as well. So yeah, I hope you guys found this useful. Learn maybe a thing or two, and if you've got any questions, feel free to let me know.
Yeah, thanks, Jan. It's really been a whole session, I think a master class. I think you've opened up lots of the canker worms. They've seen lots of things and lots of flaws, lots of things that we can learn from. So we are really, really grateful. Myself, I've been taking down notes because one of the projects I'm working on is trying to cut costs. So I've been taking down notes and I've really gotten lots of insight. And I think there's more research I have to do on some of the things you said.
Yeah, just going through the chat as well.
Yes, you can. Yeah, you can.
Okay, yeah, couch book from it's really nice. I think getting another from my team. Yeah, thanks, Daryl. They're really good guys as well. They're really nice people, and yeah, they've done a good job with the book.
One thing I'm
Uh,
mentioned, yeah, in your talk that we use a lot for really probably more non-serverless stuff is the anomaly detection stuff that they have in AWS.
right.
Like
Yeah.
I get emails every day from all of our accounts of all these anomalies. I'm not sure how well it works in the serverless case where things are kind of spinning up and down all the time, but do you have any experience with that?
Yeah, the anomaly detection. What service do you have that on? Do you have that just on the like EC2 or something like that?
I basically have it on everything in our account, anything that is an anomaly compared to the previous days for all services. You don't really specify the services by default. You just say, hey, if there's something that's
Okay.
normally happening. And I do get those reports a lot, and we found a lot of things that were things people forgot or people spun up and kind of went out of control. And it's a little bit delayed, like you say, with the alarms and stuff like that. But I find that it really helps. I just don't know if anybody's really using that in cases with Lambda and other serverless components. That's all.
Yeah, with Lambda, it's the same thing should apply as well. I mean, the main challenge there really is just that it's monitoring the cost for individual functions. I'm not sure how useful, how noisy that's going to be. I've never really used it because most of the time I just find that the cost for my Lambda functions are never that high. Just very few cases where I see a surprise in terms of cost for Lambda, even though everybody worries about it, but it's never really happened. Apart from that one customer but that was just one function essentially, and the anomaly for them would have been explained by, oh, we added more memory, so we can expect this to happen.
Yeah.
What they didn't expect to happen was the fact that they weren't getting the corresponding performance improvements, and that's why the cost actually ran up. So having that anomaly alarm probably wouldn't have helped them overall. But yeah, with the things like Lambda, no, you're not the fact that things are spinning up and down doesn't really matter because you're still just monitoring the cost for the function. So if there's something weird going on, that suddenly this function normally once a day and suddenly now it runs 10,000 times per minute. So suddenly you see a big spike in that. So maybe something like anomaly detection can be quite useful to identify that the spending pattern has changed. Maybe it's not to do with your any sort of architectural change. Maybe it's the fact that we have something going on. Someone when we were being we were hacked and someone was able to, or something happened. Some other team triggered our function much more times than we thought. There's some kind of infinite loop going on. So it can be useful as to like early warning detection. So yeah, I can see value for it. I just not had the cases where it would have helped.
It definitely works in a container-based environment. So we were using a mix of serverless and container-based
Right.
environment. We've had many cases where some container gets stuck and it's been running for like 3 days, and
Right.
it's very helpful with things like that for sure.
Yeah, I think with containers, the thing with Lambda is that if you are, well, I mean, depending on how you structure your application into Lambda functions, if you've got a Lambda lift, then it might work better. The main thing is just that when you are spreading things out into much more fine-grained single-purpose functions, then the variance there can be quite a lot, and it can be quite noisy depending on how traffic changes to specific routes from one day to another. Whereas if you have like a Lambda lift, one function that handles all the routes, then everything is going through, all the traffic funnel is through the same function. So even if there are huge variance between the traffic to a single route is different, but overall the traffic is somewhat following the same band. So you may have a better experience with anomaly detection with like a Lambda lift, similar to like what you have with container, where workloads are more sort of aggregated into one sort of resource that are being monitored compared to single purpose functions handling individual routes, which is still I guess the thing that I tend to do mostly.
Thanks.
Okay, that's interesting. Hi, Aaron, how you doing?
Good, good.
Yeah, you're
Yeah.
welcome. Yeah, so how was the session with Jan? Anything to ask, Jan?
I think it was,
For me,
Yeah, I mean Aaron. I mean Aaron.
yeah, yeah, no, this was good. I think this was an awesome session. For those that aren't aware, so I work at AWS. I'm a solutions architect here, and cost saving is one of the things that I do like on a daily basis with my customers. And some of the things that Yan mentioned are the things that we see with our customers every day. The two that I was going to highlight that are kind of like quick wins typically when I'm working with customers are things like Graviton. So I know Yan mentioned that switching the architecture over to Graviton, obviously doing like some baselining on performance to understand if you're actually seeing either an improvement or baseline performance, then you have the cost savings.
yeah,
But this is often a thing where, especially with like AWS managed services, just telling the customer that, hey, have you tried switching it to Graviton? Then they save like 10-20% just by making that config change a lot of times. So I think that is like the one area that I see a lot of. And then the other one is For customers that have like a steady state architecture, they're not changing things, they expect it to stay the same more or less for the next year or two. Then there's cost savings plans that they can commit to. There's compute savings plans they can commit to, which can net them even more savings. So those are things I typically see in my kind of day to day.
Yeah, there's also a funny one with Lambda as well, the provision concurrency, which is for most people feels like, oh, this is more expensive because they're paying for uptime. But if you like I say, if you've got a really steady state, you're getting steady, X number of requests per second constantly, and you can project that, then you can actually save money with provision concurrency. I think that we worked out to be like, if you can get like a 60 or 70% utilization, it's actually cheaper to run on provision concurrency than it is on the on-demand
For
concurrency
sure.
as well.
I really like the reference to the like the different laws you
Oh
had, and you
yeah, yeah,
highlighted the two of them. Law two, I think, really resonated. So I'm working with startup customers, and for startup customers, they are constantly chasing funding rounds, right? And
right.
when they can show that their costs to onboard new users is correlated to their revenue growth, it makes it so much easier for investors to say, okay, well, clearly you have this margin. If I invest this amount of money, you'll return this amount for that investment. When that's correlated, like that second law was highlighting, it's so much easier for startups.
Right. So because the startups are more, they care more about unit costs because that's the reporting they need for funding. I think that's something that you don't see in enterprises where people just see one blob, one number. They have no idea on the unit cost and also the unit opportunity in terms of what people actually want to use because we charge them one price. We have no idea, if any particular feature contributing to increase in revenues or decreases in revenue or whatnot. But I think, yeah, definitely in startups, so that's something that's people pay more attention about. I was talking to I forgot who it was I was talking to, but someone was telling me again, they got their own two-person startup, and this guy was talking to his co-founder. He's like, "I'm convinced I'm adding this feature, people's gonna sign up more, and we're gonna make way more money." But and his founder said, "No, it's not gonna happen." So but because he did everything serverless, so he would to launch it, he would capture the actual traffic going to that new thing that he's got, and he was able to calculate how many people actually converted, therefore the revenue sort of shared of that based on that feature, but also what's the cost for that. So they were able to work out that, yeah, this feature actually loses the money. So they tried it for a little while, realizes the economics, it doesn't work, and so they eventually canned that feature. But having that fine-grained sort of, I guess, the visibility into cost and where things are flowing to. I think Daryl mentioned the FinOps. That's exactly the kind of thing that the server is actually really good for exposing just that unit cost for specific things.
Yeah, interesting. Any other questions? Any you can turn on the mic and ask or in the chat. We are almost at the top of the hour, and it's been an interesting talk. Yeah.
Well, yeah, I'm going
Any
to take a lot of the things that Jan's mentioned here and iterate through them and make sure we're actually following all of these in our organization because I think there's a few that I hadn't really heard of before. So that's great. Thank you very much, Jan.
Good, no worries.
Okay, anything else from anybody else? Okay, so we don't have anything else. I'll say thank you so much. Thanks for attending as well. Daryl, Aaron, you're always there. And Jan, thanks for taking your time to come share us this knowledge, a master class. It's been
Thanks
very
for
interesting.
having me.
Yeah, so we are very grateful and we hope to have you again. Come talk to us some
Yeah,
other time
anytime,
as soon as
anytime.
possible. Okay, thanks so
Thanks,
Thanks,
much.
Jan.
Jan.
Thank you, everyone. Okay,
Okay,
bye.
bye. Bye. Yeah.